Hi everyone, so we're going to talk about municipal solid waste today. So municipal solid waste are all the materials that are thrown away from homes and small commercial establishments and then collected by local governments. So municipal solid waste is stuff that's collected from by municipalities from households, small businesses, and institutions. Municipal solid waste is different from hazardous waste, and this does not include wastewater because that's a liquid waste. The disposal is done by local governments, and our taxes pay for it. About 60% of municipal solid waste comes from residencies, and then 40% comes from commercial and institutional facilities. Other types of waste include agricultural waste, mining waste, and some industrial waste. Those kinds of waste are typically deposited and processed on site rather than being transferred for disposal. So the municipal solid waste system is different than an ecological system. An ecological system, waste gets broken down by decomposers and detritivores, and in that way, waste from one organism becomes the source of energy for another. So municipal solid waste, it's not being recycled as efficiently in that case. The waste from one thing is not becoming the source of energy for another thing, right? Oftentimes, there is some recycling that happens, and we'll talk more about recycling and repurposing. But most of municipal solid waste is just being thrown away in a landfill, or it's being recycled but not indefinitely as you would have in an ecological system. So to give you an idea of how much waste is being generated, waste generation in 2011 was on average 2.0 kilograms per person per day. That's about 4.4 pounds per person per day, and this is in the US. How much waste we generate varies by season of the year. It can also vary with the socioeconomic status of the individual generating the waste and with geographic location. What's interesting is some indigenous people create virtually no waste per day. So they tend to exist more in this ecological, in more continuously into their ecological system. The highest proportion of municipal solid waste is paper. So paper makes up the greatest proportion of municipal solid waste. Other big contributors to municipal solid waste are yard trimmings, metals, glass, plastics, some food scraps, and then some miscellaneous stuff. So this municipal solid waste is a combination of organic items like fibers and metals, and then plastics made from petroleum. Packaging and then transporting of goods can create some of this municipal solid waste. Some of these items can remain in our consumer use system for a short period of time, or they can remain in our system for a long period of time. Think of the difference between a ceramic plate versus a paper plate. Paper plates are being thrown away rather quickly, whereas ceramic plates are lasting much longer in the consumer use system. So when we talk about the waste stream, this is the flow of solid waste that gets recycled, incinerated, placed in a landfill, or disposed in some way. And we have largely become a throwaway society. So increased wealth and industrialization, along with cultural changes, have created this throwaway society. Rather than buy more durable items, we go for ease of use, and we buy more disposable items that are easily thrown away. We often don't try to fix things. We rather just kind of throw it away and get another item. We also, companies have marketed this planned obsolescence, right? So they actually create products that aren't going to last as long in hopes that, when it's breaking down, then you'll just throw it away and buy a new one, and they'll make money in that way. If they made products that lasted really well, then you would never have to buy that product again. So e-waste is actually a pretty small component of municipal solid waste by weight. This has to do with like consumer electronics. but it can have a really great impact on the environment despite its pretty small percentage of municipal solid waste. These electronic items are pretty difficult to recycle because they're made up of many different pieces that are hard to separate. So they have metals, they have plastics, all of those individual pieces that make up these electronics are really hard to recycle. So here's like the first phone I ever had, and here's a phone that I had recently. And a lot of times companies make these phones to not last very long in hopes that you'll just upgrade to the next available phone. So we're constantly upgrading what we have and not, being happy with the older stuff. Also, with this electronic waste, they contain heavy metals that are toxic, and if those heavy metals are exposed to water, the metals can leach into groundwater or surface water. So even though the percentage of e-waste is small, because it's not easily recycled or dismantled after disposal, you can't recycle them very well. And then they also contain a lot of heavy metals that are toxic and can leach into groundwater or surface water. So our municipal solid waste is composed of several types of items. So we've got glass, metals, plastics, paper, yard waste, food scraps, etc. And within these smaller categories, we have a few larger categories of defining municipal solid waste. And that is durable, non-durable, and compostable items. So durable goods, durable items, are the ones that are going to last for years. This is like that example of the ceramic plate. You're going to reuse that ceramic plate over and over and over again versus a non-durable item like a paper plate that you would use once and throw away. So non-durable items are disposable items. They're something that you use once or maybe just a couple times and then you throw it away. Durable items are ones that would last for years. And then we also have compostable items, and these are things that could break down, they could decompose, they could release nutrients back into the environment under the proper conditions. Now, the removal of compostable materials, could actually reduce municipal solid waste by 34%. These are probably removed from municipal solid waste most easily and would make the greatest impact. So there's a bunch of different waste management solutions. We're going to get to landfills and incineration in a minute, but in terms of waste management solutions for stuff that doesn't necessarily need to go into the landfill, the best waste management solutions are these right here: waste reduction, reusing, recycling, and composting. You guys have probably heard the 3 R's: reduce, reuse, recycle. Reduce, reuse, recycle is in that order because reducing is the preferred thing, and then reusing would be next preferred, and then recycling kind of the last option. So waste reduction is just producing less waste, and some areas are trying to cause incentive for waste reduction by having a pay-as-you-throw way of dealing with waste. So you produce more waste, you end up paying more for the disposal of that waste. You produce less waste, you don't have to pay as much for its disposal. Other ways of reducing waste: using your computer to lessen the amount of paper. We do this a lot in class. We try to not use tons of paper. Or going to the coffee shop and with your disposable coffee mug, your reusable coffee mug, to reduce using another paper cup. Right? Making products with less material, that would be a way of source reduction, right? Or reducing how much waste is going to be produced. Like this, you might have seen like water bottles, it says uses 30% less plastic or something like that. The next best option is to reuse items. So making reusable items, making items last longer so that they can be reused. And then like this would be like your Nalgene bottle. You're going to reuse your Nalgene bottle more than you might reuse a disposable plastic bottle. Recycling is where you take a item and you it gets remade either back into the same item or into a different item. So turning waste items into new products. This can be with paper, glass, plastic, metals, yard waste, textiles, or old tires. Right? And then lastly is composting of organic material. So again, this is just an example of source reduction, right? So waste reduction, making bottles with less plastic, maybe not even packaging the potatoes in plastic, just having them be free floating like this. This is an example of source reduction. So reusing items. What types of things are optimal for reuse? That would be stuff that is more durable. And then when is reuse not the best option? Sometimes reuse involves expenditure of energy and generates waste. And in that case, if you have an expenditure of energy in order to reuse something, then sometimes the cost will exceed the reducing the use of something, and it's preferable to just use a new material. So with recycling can be a tricky thing because yes, recycling is really great, but it depends on how something is being recycled. It's not the best option. Reducing is always the best option. So recycling is this process when materials that were destined to become municipal solid waste are collected and then converted into raw materials, and then those raw materials are used to produce new products. And there's a couple different kinds of recycling. You can have closed loop recycling. This is where the original waste material is made back into the same material without being changed significantly, right? So an example of this, like aluminum cans, are a great example of closed loop recycling. Aluminum cans are just aluminum, so that aluminum can then be melted down, re-rolled, and made back into the same aluminum cans. Right, so aluminum cans are pretty easily recycled back into aluminum cans. So this sometimes closed loop recycling is also called primary recycling. Open loop recycling or secondary recycling is where you have something that gets recycled and then it gets made into different products, and then those different products may or may not be recyclable without modification. So this is often not the preferred option because yes, it's being remade, but sometimes the remaking of that product requires a lot of energy. And then another problem with this is, yes, you might make this new product from recycled options, but that new product isn't going to be recyclable. So there's going to be an end point where it's still going to end up in a landfill. An example of this is like you might have seen like carpet being made from plastic bottles. That's great because it's extending the life of those plastic bottles, but that carpet is not going to be recyclable, so eventually that carpet would just end up in the landfill. And then you've also used some energy to make those plastic bottles into this carpet. So composting is a great option. This deals with organic materials that can break down. And organic materials in landfill take up a lot of space and they're unstable, and in a landfill, they would decompose anaerobically and produce methane gas, which is a greenhouse gas that's even more potent than CO2. So composting creates organic matter or humus from decomposed materials under controlled conditions. And then you can use this compost and actually enhance the soil structure and CEC and fertility. So stuff that can be composted are vegetables and vegetable byproducts, like corn stalks, grass, animal manure, yard waste, paper fiber that can't be recycled. Meat and dairy products don't decompose as easily, and they often create these foul odors. And you would put all this compost into a compost box or drum that can be easily mixed. And there's a few things that you need for composting. First, you need an optimal carbon to nitrogen ratio. And the best carbon to nitrogen ratio to support microbial activity is like 30-1. So that's 30 parts carbon to 1 part nitrogen. So carbon materials, you often hear of them as being like brown materials. So that's stuff like dried leaves, dried cut grass, paper bags, newspapers, stuff like that. That would be your carbon material, your brown material. It could be like pine chips too. And then you would want to have your green material would be like your fruits and vegetables. So you would layer your carbon stuff, your brown material, with your nitrogen stuff, your green material, and then you want to make sure this stuff gets turned over frequently, because that's going to ensure aerobic decomposition, decomposition in the presence of oxygen, which won't produce methane gas and will be more broken down more efficiently. The respiration activity of microbes generates heat that kills pathogenic bacteria. Right? And that heat relies on this optimal carbon and nitrogen 30-to-1 ratio and that turnover rate. So getting into landfills now. So this is stuff that's not recycled, that can't be composted, although a lot of that stuff still ends up in landfills. So a landfill is where you get waste that's put on the ground and then covered with earth. And you want to cover it because you don't want stuff to be biodegrading and leading to air pollution or vermin getting into your trash. Sometimes these finished landfills are actually made into parks. So this is in Virginia Beach. This is actually called Mount Trashmore. It was an old landfill that was capped, and then they've made it into this nice park that kids go and fly kites at. So, several problems with landfills. One problem is the generation of leachate. So if you remember leaching from soil, this is where water will go through material, chemicals in that material dissolve into the water, and then get carried away. Right? So the water is leaching, going through the material, leaching out these chemicals, those chemicals dissolving in water and getting carried away. If those chemicals end up in groundwater, that can be a big problem. So the water with the pollutants is called leachate. And then that leachate, if it gets out of the landfill, can contaminate groundwater. Another problem is methane production. Municipal solid waste is about 2/3 organic material. And then if it's capped, if this landfill is capped and sealed, that decomposition is happening anaerobically without oxygen. And anaerobic decomposition has this methane byproduct. And methane is a potent greenhouse gas. And if it's ignited, it's highly flammable, so it could actually lead to explosions if it accumulates and is ignited somehow. Right. Another problem is incomplete decomposition. And that incomplete decomposition is where plastics are going to resist natural decomposition. So the stuff in the landfill is not actually going to be going anywhere. To go back to methane production for a second, one way of making sure that this methane does not accumulate is to have methane collection systems. And actually, if you're able to collect that methane that's being produced in the landfill, you can exploit it and purify it and use it as fuel. So incomplete decomposition, stuff is not going to be degrading. If water gets mixed in, the stuff will biodegrade faster, but then more water, you get a greater amount of leachate. Leachate could be really toxic, so not really a win-win situation there. Settling, so this is where as waste does decompose, as it does break down, it compacts and it settles. And that can be a problem because if you have a capped landfill and you have decomposition happening, yeah, maybe that's good because then you think, oh, your waste is being reduced by that decomposition, but then the landfill can actually collapse, and that can cause structural problems in the landfill, and then stuff can escape, and leachate can escape, and that would be problematic. All right, so this is just a little picture of how long it takes things to decompose. Stuff like apple core, 2 months, that's something that's organic. Plastic bag, 10 to 20 years. Disposable diaper, 450 years. So some things greater problems than others. Right, and this is just a look at a biodegradable plastic bag. Right. So some ways that you can improve a landfill or have a better landfill, more sanitary landfill, it should be on high ground. So this makes it above the water table. That way if you get flooding, you're not going to get water seeping into your landfill. You should have a contoured floor. Right? So contoured floor, like a sloped floor, sloped bottom, that so that the water will all drain into this bottom section, and then at that bottom section you can have some kind of leachate collection system, because you're going to get leachate generated in your landfill, and you need a way to be able to accumulate that leachate and then collect it in an efficient process. The floor and the sides of this contoured floor are usually covered with clay. Clay not only is relatively impermeable to water, so that leachate won't be able to get out of the clay and into the groundwater, but it can also retain positively charged ions like metals, like we talked about with CEC. That contoured floor will also often have a plastic liner and at least 2 feet of compacted soil, which will just additionally buffer anything that might be trying to get through the bottom of the landfill. The landfill is often shaped into these refuse layers, so it's like the shape of a pyramid, and that helps water run down the sides rather than accumulating on a flat surface. You don't want water accumulating anywhere, because then there's always possibility that the water will permeate into the landfill. You want water to be able to be shed off of this pyramid shape. That way you get less infiltration and less leaching happening. So the cap, the landfill cap, is usually soil and clay, and that's installed once the landfill reaches capacity. You'll in a sanitary landfill, you'll have some kind of leachate collection system. So this is where leachate accumulates somewhere, and then you can pump that leachate out and treat it before it would have the chance to enter groundwater. Sometimes this is recycled back into the landfill, sometimes not so much. And this leachate collection system is tested regularly to make sure it's operating effectively. And in addition to that, you also want to have some groundwater monitoring wells, right? So this is making sure that leachate is not actually leaking into the groundwater underneath the landfill, right? So being able to monitor whether or not you're having any cracks in the bottom of your landfill. So siting landfills can be a little tricky because no one wants to really live nearby a landfill, and then it's also optimal if you can put a landfill where a soil is rich in clay. So stuff that's okay for a landfill: composite materials like plastic and paper, things that are difficult to recycle, glass and plastics that are chemically inert. Stuff that shouldn't go in a landfill: metals, aluminum, copper, stuff that could contribute to leaching, toxic materials, consumer electronics, appliances, batteries, substantial metals. All of those things can create toxic leachate. Organic materials can be a methane source. You want to avoid putting organic materials into the landfill as well, and can cause that settling problem as they decompose. So this is Mount Trashmore again. So another potential option for municipal solid waste is through incineration, and this is where waste gets burned to reduce its volume and mass. Right? So you burn waste materials, and that burning reduces its volume and mass. And then burning that waste, you can actually use that energy from burning the waste to produce heat and electricity. 3/4 of municipal solid waste is pretty easily combustible. So this is like paper, plastic, food, yard waste. And this definitely reduces how much waste there is. But you do still need a way to get rid of that ash. Right? So you can reduce the weight of trash by 75%, and you can reduce the volume of trash by 90%. And if you reduce that weight and volume of trash, weight by 75, volume by 90, you can extend the life of a landfill, because you're essentially compacting all of the trash that would go into the landfill into just that smaller amount of ash. So ash is this residual non-organic material that's stuff that doesn't combust during incineration, stuff that gets left over. Fly ash are the combustion gases. So this is stuff that when it's burned, it ends up in like the smoke and stuff up here. Bottom ash is residue that's collected underneath the furnace. Right, so here's your hot stuff. So your waste gets fed into the furnace. That waste gets burned. Some of the ash you can think of like the bottom of your fire pit when you're out on camping. That will be bottom ash. This bottom ash is often used to create like concrete. And then you also have these this fly ash. This is stuff that gets suspended up into the air. So this fly ash will get filtered out so that the stuff leaving the incineration is just water vapor or steam, and any cleaned gases from this part. The steam from the combustion will be used to generate a turbine that can create heat and electricity. So part of this is, you can get waste to energy. So not only are you reducing the waste, but you're also creating energy from this process, right? But you can get about 35% as much energy as coal pound for pound. Oh, here's just a bigger picture of this, right? So here's all your solid waste going to the burner. The stuff that settles out at the bottom is your bottom ash. The fly ash gets filtered out, so then you just have water vapor being released, and then that steam can generate electricity. So some problems with incineration, air pollution. See, this is mostly water vapor, steam, but it can still have a little bit of an odor to it. Incineration is pretty expensive. It's pretty hard to site a incineration factory because no one really wants to live near it. They're pretty expensive to build too. And the tipping fees, so tipping fee is how much it costs to deliver waste to the incineration or a landfill. The tipping fees for an incinerator are higher than for landfills. For your ash, if you have any metals or hazardous substances, you would need to find a secure landfill for that ash. One of the biggest problems with incineration is it actually promotes waste production. These incineration factories, they need burnable materials in order to operate and in order to produce that waste to energy process. They will compete with recycling for burnable materials, and they need to have this continuous supply of municipal solid waste in order to operate and produce that energy. So just a couple public policy things that you need to know that I will go over again. Solid Waste Disposal Act of 1965. This act gave jurisdiction of solid waste to the EPA. So the EPA is in charge of solid waste because of the Solid Waste Disposal Act. Resource Recovery Act in 1970, this directed attention to recycling programs. So this is where you started to get recycling programs. This could be easily confused with Resource Conservation and Recovery Act, RCRA. This act closed local dumps and started setting stricter regulations on landfills. So now we start to see more sanitary landfills because of the RCRA. And then lastly, Superfund Act. We're going to talk more about this when we go into hazardous waste, but Superfund Act addressed some abandoned hazardous waste sites and how we deal with hazardous waste. All right, and that's it.